Welcome to the new module, Module 3 and the lecture 3.0 of Mathmagic 2.0. Up till now, what we have done is we have looked to the behavior of change. In this module, we are going to talk about the rate of change. You have seen that how the function is behaving for a given set of input, what will be the output, and that is the behavior of change. From this particular lecture, we are going to look into that how to assess the rate of change. So up till now, we were talking about a word called change. Now we said, and we all know, that this change has got two basic attributes. One is the behavior. Now we have seen quite a lot about this behavior because we talked something about the function. We know that this function is nothing but if an input is given to it in form of input, it will give you an output. We have also seen that there are various types of functions, and we have already seen the type of functions like identity. We have seen various other function types also. So this type of function is nothing but depicting the behavior of change. Now, we also saw that there are certain limits. These limits are to pinpoint and to look to a specific close point for observation, closeness, and then we talked about the continuity. Looking to that whether the function is continuous and from going from one side to other side the limit is existing. That is, we also looked into when the limit of x was approaching to a, the input was approaching to a particular value, the number 1, the limit exists, the value of the function becomes equals to the value of the function at that given point of time. So all these particular things relate to the behavior of change. From now on, we'll be talking about the rate of change. So let us look to the example of you and your friend standing in a park at point A. He walked from point O to reach to point A. After 10 seconds moved on to distance of 5 meters. Then after 20 seconds he was again walking and the distance from you was 10 meters. Then he started jogging. So after 10 seconds he could be at a distance of 20 meters. Between these 2 points, the distance traveled by him was 10 meters earlier. Between these 2 points, the distance moved was 5 meters only. And in the very last stint, the distance traveled by him in the same time of 10 seconds, he could move to 20 meters because you know that he was running. If we look that between O to A, from this point to this point, the time was 10 seconds. The distance covered was 5 meters. From A to B, the time was again 10 seconds. The distance traveled was 5 meters because in these 2 cases, he was walking. In the next scenario, between B and C, the time elapsed we took was 10 seconds only. The time is all same in the observation. Now here, the distance traveled by him became 10 meters because at this point, he was jogging. And from C to D, the time frame we were looking was again 10 seconds, but the distance traveled was 20 meters because he was running. There was run. Now, if I draw this graph, what is going to happen? He started, remember that here it was time t and here it was distance d. If I look to the distance or the movement between point O, A and AB. It is all same. This is point A and this is point B. The time elapsed is again 10 seconds. The time elapsed between A and B is again 10 seconds, 10 seconds over here. The distance traveled by him was 5 meters and 5 meters again. Now, if I look to another scenario or the next point wherein he was jogging, the time elapsed was at point C is again 10 seconds. The time elapsed, but the distance traveled was higher. It was equal to the distance traveled in first two instances. Over here the distance traveled was 10 meters. So the line joining would be like this. And in the next 10 seconds at point D, the distance or the time elapsed was 10 seconds only, as you can see it here in this scenario. Between point C and point D, the time elapsed is 10 seconds, but the distance moved by him was very much, and he could travel 20 meters between point C and D. If I join this line, this point, C and D, the behavior would be something like this. Now, if I specifically look to the inclination of the lines, it would be something like this over here. Now, these are point A, B, C and D. Try to figure out that what all is happening. That the angle included in here is, say, alpha, is again same here is alpha, but here it is beta, and here it becomes gamma. Now the angle is of this angle is stating that angle gamma, this angle, is greater than that of angle beta, this angle, and is greater than that of the angle alpha. Means the inclination or the steepness between point C and D is greater than the steepness between point B and C is greater than the steepness of the line drawn between A and B, which is equal to the steepness between point O and A. Now here the steepness remains same, which is less than the steepness of this, which is less than the steepness of this. Here he was running, here he was jogging, and here he was walking. Now this steepness between the line joining or the points would be equated to the rate of change between these 2 points. So we know that the steepness is equivalent to the rate of change, and now in coming lectures we are going to talk about the rate of change. We already know what behavior is going to look like, and now we are going to focus on the rate of change. So in the next lecture we are going to talk about that how steepness and the rate of change is going to relate with each other. If you look to an object like this, maybe if I change the steepness of this object, what basically I am trying to do is I am changing the steepness. This is one form that it is steeper. Now this is the angle. If I make it more, now this is steeper. If the line drawn from the origin to that particular point is having this angle, which is steeper, and is having this angle, which is less steeper, the second one will always depict the slower rate of change rather than the first one, because the first one was steeper. The angle is lesser as compared to the previous state, that was this state. In the coming lecture, we'll look to the steepness and look to how steepness and the rate of change for a function or for a change is related to each other. I'll see you in the next lecture. Thank you.